Hi, this is Alex Used with Olympus Controls. Today I'm here to show you how quickly and easily we can set up remote I/O with a UR robot. Today we'll be using a UR3 6-axis arm and a MOXA IO logic remote I/O module. The first thing we need to do in this setup procedure is to set the IP address of the robot. To do that, from the main splash screen, click on the Setup Robot button, then Setup Network, then make sure we select Static Address, and set the IP address to one that's compatible with our I/O module. In this case, I know that my I/O module's IP address is 192.168.3.254. So I'm going to set my robot's IP address to be 192.168.3.1. Hit OK. For the subnet mask, we want to choose 222550 and hit Apply. At this point, we're ready to map our Modbus registers. So we're going to go Program Robot, choose an empty program for today. We'll go to the Installation tab, find Modbus Client, and then I will zoom in on the screen so you can see these next steps in a little bit more detail. So the next step is to add a Modbus register. So we hit the plus sign. We need now to tell the robot about the IP address of our Modbus device. So in this case, that IP address is going to be 192.168.3.254. Hit OK. Now we need to add the register itself, so we hit this plus sign there. First, we're going to map a digital output, so this will be an output that the robot can control. I have a relay wired up to output 1 of the I/O module, so I'm just going to select 1, hit OK, and at this point we're exchanging data. We can tell that we're exchanging data because the indicator here is green. If I zoom out just a bit, you'll be able to see my setup. So there in the lower left-hand corner, you see the I/O module itself, some terminal blocks, a relay, and a 24-volt power supply. So that 24-volt power supply is supplying power to both the MOXA IO logic module and the relay. So if I click the square here, which is the test button, you can see the light on the relay will turn on and off. And if I be quiet, you might be able to hear it click. So we've successfully mapped an output from the robot. The next thing I'd like to do is map the analog input from the I/O module to the robot. So to do that, we need to add one more register. Analog input 1 gets mapped to register 512. So I will enter that here. We want to make sure that we're using a register input. And right away we see the light go green, and we actually see a value there. Let me zoom in, show you the value that we've got. So it's hovering right around 8,000. If I turn up my power supply, that number goes up. Clearly, we're not giving the robot 14,600 volts. So we need to scale that number to make it match volts, the units of volts that we're using on our power supply. The easiest way to do that is from within your program. I'll show you how to do that real quick. So we simply go to Program, Structure. We're going to do an assignment. We'll just leave it called var_1. Now we have to choose our input, our Modbus input, and we need to divide that number by the maximum that you can get with the size of the register. In this case, it's going to be 65535. Then we want to take that entire expression and multiply it by 10. Since the default scaling of the IO logic module is 0 to 10 volts. Once we set up that expression, hit OK. And then we need to add a short wait to prevent an infinite loop from occurring. In this case, just a short 10 millisecond wait should be fine. Now I'm going to hit play to begin running my program. Head over to the Variables tab so that I can see the current status of the variable. And now if I zoom in here, you should be able to read our voltage. So that var_1, that is mapped to the Modbus register, or scaled from the Modbus register. Currently it's reading 2.2, which makes a lot more sense for a power supply. I'm going to turn up the power supply just a little bit. Alright, so right now on the screen we are reading 6.0, and if I zoom out a little bit and pan over to my power supply, sure enough, the power supply is supplying 6 volts. With that, I'll conclude the video. Thank you very much for watching. If you have any additional questions, feel free to visit our website at www.olympus-controls.com.